inviting me to Bogota to come have a conversation with you about what's happening in Brooklyn. It's been a really nice trip. My first time to Colombia, to Bogota for sure. I'm very much enjoying it. So let me start by telling you a little bit about LO3 Energy. So the majority of my company comes from either financial or utility backgrounds. So a good portion of my team has worked with some of the largest utilities in the US, working on emerging technology programs, new technologies, demand response, energy efficiency, distributed generation, or a finance background. We also have a significant tech background in the company, but really feel like there needs to be a focus in order to shift markets from sort of the centralized way that they work today to a decentralized market of the future. You have to understand how the energy markets work today. And you have to have people who know how to work with policymakers and regulators, as well as people who had experience taking technologies across the adoption curve. Because what we're doing at this company is really giving a lot of different choices and new choices to consumers that they've never had before, with ways that they can use energy. So for a bit of background on Brooklyn and the US as a whole, I'm going to talk a little bit about the market and why we got pointed in this direction. This is a really interesting graph. This is done by Lawrence Berkeley Laboratory every year. So if you look at this graph, on the left-hand side you can see the source fuels. So the coal, the wind, the natural gas, where the energy actually comes from, and the efficiency that it gets distributed through the grid to its end use. The really interesting thing to note is that the top half is the amount of energy that's wasted as loss in the system, either through conversion or transport or efficiency losses in the grid. So in the 18 years that I've been in the industry and been watching this, it's never really changed. Those losses haven't really gotten that much better. So right now, about 60% of the energy that we produce or take out of the ground to produce electricity in the US is lost as waste. So it became pretty clear to me early on that we didn't really have an energy crisis, we have an exergy crisis. So energy is made up of two components. Energy, which is the amount of energy that you just can't recover, it will be lost as heat. And exergy, which is the amount that gets turned into useful work. So our focus is really on how to increase the productivity of this energy and turn it into useful work. The other big trend that got me focused on this in about 2012 was the rapid adoption of solar and the price drop that we're seeing in distributed generation as a whole, not just solar, but wind, micro CHP. Technologies like this are really advancing quickly. In the US, you can see that the amount of distributed capacity that's going to the grid is continuing to accelerate up. Large central station power plants are actually continuing to decline. So the really interesting thing that I became aware of a couple of years ago was that about half of the PV that went into the market across the world, actually, and last year, according to Bloomberg, went onto rooftops, went onto people's houses, went onto people's businesses, went out into the grid, not in large utility-scale PV plants. So you have to wonder, why is that? There's a really interesting study done by Accenture over, I think, about 10 years, 13,000 people across the globe, really talking with them about energy and how they engage around energy. And I would encourage you, if you're in the industry, you should read it. There's a lot of really good information in there. A lot of really surprising things came out of this study for me. The one is the number there on the left. About 70% of people want to participate in an energy market right now. Not in 5 years, not in 10 years, but right now. 70% of the participants. Almost half of the participants wanted to buy energy from their local community, in their community. Distributed generation, solar, in their community. So these numbers were pretty surprising to me. I've been in the industry for a while. always tried to convince myself that people weren't that interested in energy, but it's becoming clear that people are actually becoming more and more interested in energy. So that lines up a couple of problems. So the utility grid of today, in most of the developed world, if you have a utility grid, is built unidirectional. So you built that grid so it pushes electricity from big power plants to the grid edge. It's very brittle, fragile grid. As you start to put distributed generation out of the grid edge, that grid doesn't adapt to two-way power flows very well. It creates a lot of problems. The other big problem is that current utility business models are pretty brittle as well. So most of the utility models that are in place today are regulated. You have regulated rates of return that come off of deploying capital to build infrastructure projects. As the grid gets more and more distributed, that business model doesn't continue to work the way that it had in the past. So we're going to see some shifts. Right now, there are a lot of regulatory barriers that are in place that are limiting people's ability to do things they want, like participate in energy markets or buy distributed generation from their community. These things are being challenged right now, but there really is an onslaught. There is a real movement of prosumers, people that are interested in generating their own energy. It's not stopping. So the last big problem is that coordinating all of these distributed devices at the grid edge is not technically feasible. We're talking about billions of grid edge devices. The communications platforms that we use today can't speak to efficiently that many grid edge technologies. This is another interesting chart. So when I first started in the industry, working in California, this was the load curve. So the sun would come up in the day, the air conditioners would come on, people would go to work, and they would start using energy. So it was a nice, big, fat load curve. Very predictable, really easy to manage, lots of big base load power plants, very cost effective to feed. What's happened over time is that generation has gone into that market, distributed at the grid edge, solar specifically, and it's driven down that load curve. So now the sun comes up, people go to work, the air conditioning comes on, and the PV starts producing electricity. It actually drives this trough in the middle of that very large load curve. You can see it there. So the real problem is not this trough. You can manage this trough by managing your grid assets differently. The real problem is the shoulders. So the shoulders on that edge are really hard to manage. You have to use peaker plants, and you have to use them in a very tight and controlled way to manage those things because the edges aren't predictable. They're really frothy. There's a lot of change that happens there. And they're difficult and expensive to manage. The other issue is that some of those big central station power plants that were providing base load have now been turned into peaker plants because they're already in place and they're more cost efficient to run. So they're having to run them like peaker plants. So it's really shifted significantly the way the grid and the market runs in California. So in response to that, there have to be some significant changes in the way that the grid works, as well as regulation and business models work. So the architecture of the grid itself needs to change. The grid has to become more accepting of loads at the grid edge, of distributed generation. I just came back from Australia, excuse me, and in South Australia, about every third house has PV on top of it. Every third house. You can't look down the street and not see solar panels on top of somebody's roof. So they're in the middle of this right now. They have to actually re-architect their grid to accept these two-way power flows. One from large coal-fired power plants down there, the other from distributed wind and solar resources. So in order to do that, the transportation of this energy is going to become critical. How you move energy back and forth in the distribution system is going to become the real focus of utilities in the near future. Transmission lines to big central station power plants are going to become less and less used as these technologies move into the grid edge. So it's going to necessitate a change in the market as well. So the incentives for building a big plant are still going to be there. The grid's not going away. It's just changing. But they're not going to be as big as they were before, because now you're going to have competition, in some cases, from your own consumers, from people who were buying electricity from you before. So the markets are going to have to change. The architecture of the grid is going to have to change. The grid is going to have to become more resilient, more adaptive of distributed loads at the grid edge. And utilities, TSOs, transmission system operators, distribution system operators, are going to have to be compensated in different ways. So I spent the last year flying around the globe, talking to regulators in Germany, in France, in Australia, in the US, about some of these models and the different ways that you can manage some of these distributed technologies that are moving into the grid edge. And of course, the platform that we're working on to do that. So the platform we're developing is based on blockchain technology. Who's heard of blockchain at all, besides today? Nobody, great. Anybody heard of Bitcoin? 1, 2, oh, there we go. So people have heard of Bitcoin. All right, so Bitcoin is not blockchain. Bitcoin runs on a blockchain. So blockchain is really the underlying sort of secure distributed database that network runs on. What we're doing differently with this is this is not a currency, so we're not trying to move money across this. We're actually trying to move data across this, distributed data from the grid edge in a very efficient manner. So one of the things that blockchain is really good is as transporting information in a very clear and transparent way. So what we're doing is we're using blockchain to actually design a new operating system for the grid of the future. A distributed operating system that is very cryptographically secure. It would be very hard to break into because of its architecture. It's also auditable because it is in blockchain. You have a very clear set of transactions. You can look back at any point and see what happened, when it happened, who it happened between, and have no confusion because of the nature of the technology. So the first project we're working on with Siemens is here in Brooklyn. You can see the little red area there. That is actually part of Brooklyn. The carve out in the middle is about 10 square blocks, which make up the physical microgrid that we're hoping to develop there. So that 10 square blocks, at some point in the future, will actually separate from the utility grid, run on its own power, mostly CHP, combined heat and power, batteries, and of course, solar. Lots of people in Brooklyn want solar, but you're not going to power Brooklyn on solar. It's just too energy dense. So the way this blockchain technology works is that it's really a decentralized database. So instead of having a centralized database where everybody sends information to one place and then waits for something to happen and it comes back, a centralized database actually keeps the records of information and transactions distributed across all the nodes of the network. So every node in the network has the same information at the same time, which makes it really good for running a market, and actually makes it pretty good as a communications platform. So the things we're doing in our network is we're creating tokens that record the production, consumption, and grid telemetry from the grid edge. So putting things in like volts, bars, phase angle, reactive power in real time at the grid edge, and using this, or developing to use it as a grid management platform, ultimately, so that you can balance load, generation, storage, and distribution in real time at the grid edge. At this point, we've had trials in multiple countries. Our blockchain is a purpose-built blockchain. It's very fast. In order to be able to run a utility grid on it, you need block speeds to be very quick. Our block speeds take over about a second. Currently, we think we can get them down to sub-second. Once we can do that, lots of ancillary services, lots of interesting things you can do and transact across the grid. One of them is, we're testing in Brooklyn, is the idea of transacting device control. If the grid really exists to balance load and generation, then the value of a megawatt, the value of turning something off, is just as high as the value of turning something on and generating. So across the blockchain platform, we're actually allowing the control of devices in homes, in businesses, through existing building management systems, car charging, batteries, all sorts of devices at the grid edge. You can see on the right-hand side there at the bottom, those are our meters. No smart meters existed that will actually run a blockchain, so we had to build our own. So we have our own technology. These meters form the network. They actually hash the blockchain. They're a distributed mesh in a distributed mesh to actually provide the compute horsepower to run the network. So all of that needs an efficient way for people to interact with it. So everybody interacts with their iPhones today, with their telephones, You have to have a way to connect with people very efficiently and in a way that they communicate. The world is moving towards this. So we're moving towards it as well. So I want to talk a little bit about what's happening in Brooklyn. In Brooklyn right now, so we have about 65, 70 meters on prosumer sites. These are people that have PV, combined heat and power on their buildings now. Collecting information, putting that into the blockchain, the market can actually see that. I want to tell you about the community, and why the community is so interested in this. But rather than have me do it, I'd rather have some folks from Brooklyn tell you.
I'm George, this is my brother Willie. We grew up in the Gowanus, and this is our office right here. Everybody has to do their share, you know, and it's got to start someplace. Everybody invests in solar panel, or whoever can afford it, or buy power from the neighbor.
Everybody in this community has an electrical bill, right? Funny enough, the one thing you can't keep to buy in your community is electricity.
So why buy locally generated renewable energy? First of all, because you're not polluting your own neighborhood. That's the biggest thing, right? Secondly, resiliency, resiliency, resiliency.
So the next time there are these rolling blackouts or a superstorm comes through and knocks out all the power, Brooklyn Microgrid will work to make sure the lights are on in critical areas so that you have a safe place to go, get warm, charge your phone, get food, and send out emails. Just let people know you're okay.
So what the tag element in the transactive platform enables us to do is record the access electricity that a system such as Eric's PV panel here produces. It puts it on the blockchain and facilitates exchanges, transactions between neighbors.
So blockchain is really just a distributed ledger. So whereas normally, in order for you and I to share some information, we send it someplace on the internet, you send your information, the central place to figure it out and come back to us, now we both share it both simultaneously. So it allows for distributed actions, transactions, all these things that do not require a central repository.
That money that other people who consume the energy are willing to pay is going to be given to those who are producing energy, and that money will stay in the community.
I'm interested in the microgrid because I would like to sell my power locally and have the dollars stay here in Brooklyn and in New York City and go to paying workers that work right here.
Brooklyn Microgrid is community-driven and wants to provide a path to investment for people like us that never had an opportunity. People that live in places like the Gowanus houses.
So this is how it breaks down. There's a higher demand for local renewable energy. That sends a price signal to your neighbors to get with the program and invest in cleaner assets like solar power, CHP, or even batteries. Get with Brooklyn Microgrid. Together, we can clean up the air in our neighborhoods, invest in local energy resiliency, maybe even set standards for the world to follow.
BMG has taken the meter off the wall and placed it in your hands. So now you have some control over the direction of your community's energy future.
So all these folks live in Brooklyn, and if you're really interested, we have about 2 days worth of testimonials that you can watch on the Brooklyn Microgrid site. Business owners, community members, people who want to buy energy, people who want to sell energy, people that are interested in participating in platforms like these. So it's been really stark waiting for me through this process to find out how much people actually do care about energy. It's an industry we try to tell ourselves that they really don't. It's not enough money to worry about. But those states are changing. Can you advance to the next slide? No, there we go. So each one of our projects is testing a different business model, it's testing a different community engagement methodology. In Brooklyn, what we're really doing here is we're tokenizing the value of that energy, the economic value of the energy, the community value of the energy. The folks in this community are really interested in buying things from each other. This community has a strong drive for a circular economy. So people make things in the community, and they actually pay a premium for things that are made in the community. By tokenizing this energy, we can actually attach value, different values, to that underlying token. So people can, if they want to, they can pay more for energy that's produced by somebody in the community, or if the power plant was made by somebody in the community or installed by somebody in the community, or if the energy being sold and consumed by somebody else in the community, they can do those sorts of things. They can donate their energy to a nonprofit that's in the community in the future. So that's really driving a peer-to-peer market. A lot of these people deciding the way that they want to account for energy. You get lots of new and interesting suggestions about ways that people want to attach value to energy that they don't have a chance to yet today. But the thing that's really interesting is that it's driving significant interest in people producing energy. So they're seeing folks that maybe had been on the fence about installing PV panels or a CHP plant are now seeing the community around them recognize the value of that differently. So you've got a different economic return. If somebody's willing to pay you more for energy because it's clean and it's from your neighbors, then that has to factor into the cost of your system, the payback itself. But at its core, it's really driving this idea of a community microgrid. This community specifically was hit pretty hard by Hurricane Sandy that came through. So they have a really high value for resiliency that the microgrid, the physical microgrid, can provide, so that there is a place where they can go, where the lights stay on, where they can reach the internet. These folks only had about 3 hours worth of communications after the power went down. All the cell tower batteries died at that point, and you had to leave Brooklyn to go and talk to somebody. So they have a lot of different values that they will lay on top of energy. So in order to engage with them, you have to do this in really simple and efficient ways, right? Letting people choose how much they want to pay for energy. First and foremost, how much do they want to pay? Secondly, what kind of energy do they want to buy? The platform is agnostic. I don't care if it's coal, I don't care if it's natural gas, I don't care how it's made. It's all about providing choice to consumers. They get to decide. If they don't want to buy coal, they never contract for coal. If they do, they can. Same for any of the other fuel sources. The other thing, creating a value for megawatts. Instead of saying, I'm going to give you so many cents per kilowatt hour to turn things off when there's a demand call, you as the consumer get to decide what you want to have turned off and how much somebody would have to pay you to do that. So as the utility on the other side, then you've got a whole economic list of price points at which you could buy demand shed out in the community. Batteries, once we have the first batteries installed, all I really care about is I want to save about 30% of the capacity for myself. The rest I want to offer to the market. Use my battery to store energy so that you can buy great energy at night that's made in the community. So very simple ways to engage with these folks. So I said before, we're doing these demonstrations multiple places around the globe. Every continent, every country, every community has different drivers around energy. So in these first projects, we're really looking for what those core drivers are, what is similar across every single one of these projects. In Australia, we know for a fact that Australians really care about independence. If most of them would go off the grid if they possibly could, because they're just that independent. In Germany, people don't want independence. They're really driven, they're not even driven by economics, they're driven by the technological advances. So being able to control the charging and discharging of your car, being able to set your own price points, being able to value things differently, are things that folks in Germany really care about, some of those projects. In the US, it's a little bit all over the board. So we have people in Brooklyn that care very much about local environmental impacts. We have folks in the demonstration in Texas that want to micro-hedge from a commercial perspective, micro-hedge and increase the economic efficiency so that they're paying less for the energy that they would as a whole. So the demonstrations we'll do over the next year to two are really going to inform the business models that are going to drive this new distributed economy. I guess the real core of this, and this was really interesting when it happened, one of the folks in Brooklyn, after we had a focus group, said, well, wait a minute, if it's my PV panels, then they're my electrons, I should be able to do whatever I want. So when I show this slide around the globe, depending on who's in the room, some people are like, from utilities, are like, well, wait a minute, those are our customers, we better let them know that they need to work with us. Others are, wait a minute, those are our customers, and that's what they want to do. So I would say the more progressive utilities are looking at their customers, understanding what their customers want to do, and responding to that. Because if you don't, your customer might be your competitor in the near future.